In today's class, we are going to solve gate questions on permutations. First of all, I will give you all the questions so that you can try by yourself. Then you look at my solutions with tricks and techniques, and also I will explain the traps. So let us start the lecture with the very first question. You have GATE CS 2001. Pause the video, try by yourself, then go to the next question, question number 2. It's a word problem, very good question. Next question is again a word problem. I will say it as a level 2 question, not level 3. Then which is level 3 question, sir? This is a level 3 question, question number 4. This is again level 1, level 2 as per your convenience. Next question and the final question of the day, it's an easy question, level 1 question. Okay, so now let us look at the solution. I hope you have tried all the questions by yourself, then only looking at the solution makes sense. Otherwise, what's the point, right? Okay, question number 1 in front of a screen. How many 4-digit even numbers have all 4-digit distinct? A, B, C or D? GATE CS 2001. So pause the video, try, look at my solution. The correct answer is option B. 2 key things you have to understand. First, 4 distinct digits, which means repetition not allowed. Second thing, no direct formula is there. Permutation, combination, no direct formula. In the counting principle, I have explained how to count and get the answer. Also in the permutation class, I have explained how to deal with this kind of questions, right? Going from left to right, right to left, what are the traps, everything is explained in detail. So all those concepts will be useful in solving this question. So first watch my conceptual lectures, then only come to the GATE PYQ lecture. Otherwise, you won't be able to connect. Now, coming to the solution. First point, given data we have to write 4-digit even numbers are there, distinct is the possibility. Now since 4-digit numbers are there, what are the single digits we have? From 0 to 9 we have 10 such digit, but we cannot place randomly and say we can say 10 into 9 into 8 into 7 and that's how your answer is, final answer comes out. That is not correct. Constraints we have, as per the constraints we have to do the filling. Constraint number 1, last digit should be even, then only the complete 4-digit number would be 4-digit even number, right? So last digit should be compulsory even. What are the possibilities? 0 can come or 2 can come, 4, 6, 8, these are the possibility, right? Now the problem is with the 0, because 0 can overlap, right? 0 can come here or come here or come here, but cannot come here. Why? Because if 0 comes here, then it is no more 3-digit or 4-digit number. It becomes a 3-digit number, right? We are in a search of 4-digit number, hence 0 cannot take this place. Then how to fill? A lot of students, what they do is they say, sir, if you want to solve this kind of problem with the constraints, make cases and solve. Which kind of cases? Sir, fix the position 0 and solve. In the class we have done similar kind of stuff. So yes, make cases and solve. Please make a note, 0 is present, so be aware what would be the cases. 0 at the last, 0 at the second last, 0 at the third last. 0 cannot come at the fourth last because then it will become the 3-digit, but we do not need that, we need 4-digit number, right? So a lot of students just leave at the 3 cases only, which means we have only 3 cases. No, 0 can go outside also, which means 0 is not present in your 4-digit number. So that case also you have to consider. A 4-digit number where 0 is not allowed. Okay. So these are the 4 cases. If you fill that correctly, you will get your answer. Starting with the first case where 0 is at the last, it is fixed. Now we have 3 dashes and the possibilities are 10 digits are there from 0 to 9, 10 digits, 1 is gone, so 9 is left. Anyone can come here, right? So 9 possibility. Once it is done, then it cannot go further. So for the next dash, we have 8 possibility. Once it come here, it cannot go further. So out of 9, 2 is gone, so only 7 is left. So the numbers where 0 is at the last and 4-digit number would be created, which is a 4-digit even number from this scenario is 9 into 8 into 7, which is 504. Is it clear? Very simple, right? Going to the second case, which is more critical, because now 0 is taking this position and you cannot say 987. Why, sir, you cannot say 987? Because we need 4-digit even number. Because of that even, last digit should be filled first. 2, 4, 6, 8. These are the only 4 even number possible. Why not 5? Previously you said 5 digits are there for the even. Because 0 is already fixed. Therefore only 4 even digits are left. So 4 possibility for this. Okay. So now you can see we have only this 2 dash where 10 digits are not left. 1 is gone here, 1 is gone here. So 8 digits are left. So this blank get the 8 possibility. And once it's done, then the next will get the 7 possibility. So the final answer for this case is 8 into 7 into 4, which is 2 to 4. Understood. Going to the third case where 0 takes the third last position. Again same scenario, last should be even, so 4 possibility. Then out of 10, 2 digits are gone. So for the first blank only 8 possibility. Then for this remaining last blank it would be 7 possibility. So 8 into 7 into 4, that would be 2 to 4. Coming to the final, which is very good example where 0 is gone. So out of 10 you have 9 digits left. So a lot of student thinks 9 into 8 into 7 into 6 would be the answer. Wrong. Even a 4 digit number you need, therefore last blank should be filled first. So for last we have 2, 4, 6, 8, 4 possibilities. So 4. Once it's done, now you have to start from left to right. Now you have to say out of 10 digit 0 is gone and last blank 1 digit is gone. So out of 10 8 is left. So for the first blank 8 possibilities, second would be 7, third would be 6. 8 into 7 into 6 into 4, because this is also having 4 possibilities, right? So the final answer is 1, 3, 4, 4. Add them all, you will get 2296, and that is the correct answer, which is option B. Now this is method 1, fixing zeros like this to get the answer. There is also method 2. As explained in class, there are various ways to solve this kind of problem. Some students might think in this way: 0 I fixed at the last, and if I do that, the case 1 which I explained here, same to same replicates, and 504 possibilities are there. But for the case 2, 3, 4, we can combine them and we can make it 1. How can you do that, sir? 2, 3, 4, combine them and make it into 1. See, like this. I will say dash, 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 dash. Okay. Last should be even. Since here even last was not present, so this case was such where 0 is at the last. Next case I am taking such where 0 is not at the last, but even numbers can have the last position. So 2, 4, 6, 8 can take that position, which means 4 possibility. Now coming to this blank, we have to go from left to right to avoid any miscalculation. You know, if I go from right to left, miscalculation happens. Explained in the class already. So always go from left to right when 0 is present. So we'll start with the first blank and we'll say that 0 cannot come here since we need 4 digit number. Also the number at the unit place which is gone cannot repeat here. So for the first blank 2 numbers are gone. Out of 10, when 2 is gone, 8 is only left. So 8 possibility. For the next, it won't be 7. Sir, why it won't be 7? Because 0 can come here. Okay, 0 can come here. So now see carefully. 1 digit gone here. For this blank I am explaining why it is 8. 1 digit gone here. 1 digit gone here. So out of 10 digit, 2 is only gone. So 8 is left. So here we have 8 possibility. Understood. Then what about this blank? Will it be 8, 7, 6? What it would be? See, 1 is gone here, 1 is gone here, and 1 is gone here. 0 can be possible. So out of 10, 3 is gone, 7 is only left. So 7 possibility. Understood. If understood, then I guess this case is pretty much clear, which contains all these 3 possibilities in just one scenario. So 8 into 8 into 7 into 4 would be 1792. Add them all, you will get 2296. Understood. So there are 2 ways to solve this kind of question. This is a very critical way to think. If you can think it wisely in the GATE exam, then go for it. Otherwise, this is a very layman technique to solve the question. Okay, but confidently you can comment on the answer. Coming to the question number 2. N couples are invited to a party with condition that every husband should be accompanied by his wife. However, a wife need not be accompanied by her husband. Okay, the number of, I won't comment anything, otherwise feminism, feminazist will comment on the video, so I will refrain from doing any comment. The number of different gathering possible at the party is what? A, B, C or D? It was asked in GATE CS 2003. Pause the video, try, look at my solution. Then the answer is option B. Why? Constraint is very important. See, we have n couples, okay? We have n couples, first couple, second couple, third couple, fourth couple, till n couple. How many choices they are getting? That's what will decide the answer, okay? Now, for the choices, the constraint is n couples are invited to a party with condition that every husband should be accompanied by his wife. So, if I make a couple husband comma wife, so which case is possible? Here, every husband should be accompanied by his wife. If husband is coming, then he should be accompanied by his wife, then only a valid case. What if husband is coming and wife is not coming? Then he is not allowed, not a valid case. That's what this line says. But coming to the wife first scenario, a wife need not be accompanied by her husband. She can come alone or she can come with the husband. Okay, so there is no constraint on the wife. So if wife comes and husband does not come, it's okay. If wife is not coming, husband not coming, that is also okay, because nothing is mentioned when husband does not come, what happens, when wife does not come, what happens, right? The constraint only is when husband comes, wife is compulsory. So husband come, wife is compulsory. Husband comes, wife is not coming, not a valid case. And then when wife comes, then husband may or may not come. So when wife comes, husband is not coming, valid case. When wife comes, husband comes, a valid case. But when both are not coming, when husband is not coming or wife is not coming, that thing is not mentioned, which means by default a valid case, right? So if this is the valid case scenario, these are the choices for the couples. The number of different gatherings possible at the party is, which means first couple get 3 choices, first, second, third, right? 3 choices. First couple got 3 choices. How is the 3 choices? Just to explain, husband, wife coming, good. Husband comes, wife does not come, not allowed, so not a choice. Husband is not coming, wife is coming, good. Both of them are not coming, that is also good. 3 choices. Second couple also got the same 3 choices. Third couple will get the same 3 choices. Nth couple will get the same 3 choices. So the final answer is 3 into 3 into 3 into 3. Why multiplication? Because all of the couples should come. First couple and second couple and third couple and up till nth couple. Everyone should come in the party. Since and is there, multiplication will happen. So 3 into 3 into 3 into 3 up till n times, it would be 3 to the power n. Okay, so the answer is option B. Understood? Let us go to the next question. Question number 3 in front of your screen. Remember that whenever word problems comes into picture, do not get afraid. A lot of GATE aspirants get afraid by seeing a very lengthy word problem. Reason being, there is no direct formula to get the answer. Indeed, but whenever word problem comes into the picture, decode that into simple maths, find a logic to get the answer. That's the process for every word problem. Same process I'm going to use for this question. The question says a pennant is a sequence of numbers, each number being 1 or 0. An n pennant is a sequence of numbers with sum equal to n. For example, 1, 1, 2 is a 4 pennant. As you can see that 1 and 2 are the only digits used while making a sequence as per the data 1. Only 1 or 2 can be used, other numbers cannot be used. And what is a n pennant sequence as per the question, where sum of the digit is coming equal to n. Yes, 1 plus 1 plus 2, sum of the digit is 4, right? So 4 pennant ordered set makes sense. The next thing, the set of all possible 1 pennant is this thing, which makes sense, sum of the digit is 1, right? The set of all possible 2 pennant is 2, 1, 1, which means this 2 ordered set is coming in 2 pennant criteria because sum of the digit is 2. This is also coming in the 2 pennant criteria because sum of the digit is 2, and they are making them into a set. That's all. Okay, so set of all possible 2 pennant is nothing but making the curly brackets, and that's it. Coming to the third point, where set of all 3 pennants is like this. And then you have to note that the pennant 1, 2 is not the same as the pennant 2, 1. See carefully. 2, 1 is not the same as 1, 2. This is what they are saying. If that is the scenario, the number of 10 pennants is dash. GATE CS 2014 set 1. Try this question by yourself, then look at my solution. I know a lot of students, they will say, sir, super easy question. I have analyzed the word problem. 1 pennant, 1 ordered pair, right? 2 pennant, 2 ordered pair, and then 3 pennant, we have 3 ordered pair. So 10 pennant, 10 ordered pair. Very good. That is the wrong answer. Use logic to get the answer. First of all, write down the criterias. What are the criterias? First of all, 1 comma 2 is not the same as 2 comma 1. This indicates order matters. And order matters means permutation question, not a combination question. Now second thing, we have to use 1 or 2, this digit only. Okay, digit 1 or digit 2 only. And the requirement is we need a number of 10 pennants, which means ordered pair such that sum of the digit in that ordered pair is 10. So how many such ordered pairs you can generate? This is what the requirement is. You have to find the number of ordered pairs such that in each ordered pair sum of the digit is 10. Now how to think on the logic? To think on the logic, I came to the given example that 1 pennant they made this ordered pair 1, makes sense. For 2 pennant they made this, for 3 pennants they made this. So basically, don't you feel this is kind of arrangement of digits 1 and 2 in such a way that the sum of those digit comes out to be 3 for this 3 pennant criteria, right? See, this is ordered pair which is made out of a digit sequence, which is 1s and 2s are used, where sum of the digit is coming out as 3, right? So basically this is arrangement of 1s and 2s in such a way that the sum of the digit is 3. Similarly, our requirement says that sum should be 10, which means all the arrangements of 1s and 2s such that sum of the digit comes out to be 10. That's all. This is what the logic says. Once you understood this logic, then we can make table and get the answer. Arrangement of 1s and 2s. So arrangement question, it's like the letter arrangement but repetition happens, so divide by that, right? So type 4 in the permutation what we have studied. So this is a type 4 question of permutation. Okay. But cases are not specified. I have to create the cases and then add up all the cases. Case 1. How you will create a sequence of 1s and 2s where the sum is 10. I can say all the digits are 1s, which means 10 times 1 is coming, 0 times 2 is coming. Then you can see like 1, 1, 1, 1, 1. If I have such 10 digits of 1, sum is 10, a valid case. So tell me the number of ordered pairs you can generate from this. It would be only 1 since everything is 1, 1, 1. So only one case. If you want to go with the maths permutation type 4 formula, you will say 10 factorial, all the 1s are arranged among themselves in 10 factorial, divide by the repetition. 1 is repeating 10 times, so divide by 10 factorial. So this is 1, which logically also I told you that one case only will happen. Now coming to the second case. Second case, can I take 9 1s and then some x 2s to get my sum as 10? It won't happen. It won't happen, right? 9 1s will make it as summation 9 plus what you will do to make it 10 if 2s can be used only. It's not possible, right? So if it is not possible, that case won't come where 9 times 1 is coming. Okay, so we have to go to the next. So, oops. Okay. So we have to go to the next case. What is the next case? 8 times 1 digits are coming. So summation is 8, right? 8 times if 1 digits are coming, then the summation is 8. Then one time you take a 2 digit number. So summation is 2. Overall the summation is 10. Yes. 8 times 1 digit will give you 8. 1 time 2 digit will give you 2. So 8 plus 2 will make it 10. Okay. So this is a valid thing. But since if I just make the scenario 1, 2, 3, 4, 5, 6, 7, 8 and 2. Tell me the number of ordered pairs which I can generate. You know that 2 can come here or come here or come here. So there are many such ordered pairs which I can generate. So manually if you go, it will take a lot of time. So how to do it mathematically? If this is what we have, can you represent this as letters? if we have 8 times A letter and 1 time B letter, the number of arrangements is what? Total letters are 9. So 8 plus 1, 9 letters can be arranged among themselves in 9 factorial ways. Divide by repetition part. So this ones are coming 8 times in our alphabet way. A is coming 8 times. So if 8 times is coming, 8 factorial division. So the answer would be 9 factorial by 8 factorial, which is 9. Understood? Just giving you analogy in the way which we have studied with the alphabets. It's kind of similar. If you treat ones as A's and 2 as B, this is what your arrangement of alphabets looks like, right? Similarly, we have to go for the rest scenarios. Case number 3. If 7 ones are there, then no possibility to get sum as 10. If 6 ones are there, so 6 plus 4 is 10, so 4 can be gotten if you take 2 digits 2 times. So 6 ones and 2 times 2 digit. So total we have 8 numbers. 8 numbers can be arranged among themselves in 8 factorial ways. Divide by the repetition, 6 factorial, 2 factorial, simplification gives 28. I hope how to do simplification you know very well. If you do not know, just by case, 8 factorial by 6 factorial, 2 factorial can be said as 8 into 7 into 6 factorial divided by 6 factorial. 2 factorial is 2. 6 factorials are gone, 2 ones are, 2 fours are 8, 7 fours are 28. Easy. All this are explained in the class already, so I won't repeat again and again, just to give you the idea how to solve this kind of question. Next, if we have 5 ones, then 5 plus what will give you 10? 5 plus 5 will give you 10, but 5 cannot be generated with the even digits, right? So go to the next case. 4 ones, 4 plus 6, 10, 6 can be generated if you take 3 times 2s. So this is a valid case. How to get all the ordered pairs? 4 plus 7, 4 plus 3 is 7. So 7 such digits can be arranged among themselves in 7 factorial. Divide by the repetitions, 4 factorial, 3 factorial, so 35. Similarly, 2, 4 is the case. So 2 plus 4, 6 digits, 6 factorial ways. Divide by the repetition, 15 is the answer. And final case, 0 ones and all the 2s. Okay, so 8 2s if I take. Oops, this is a wrong case, because 8 times if 2 you have, it would be 16, not 10. So summation 10 if you need, it should be 5. Okay, so yes, 0 times 1 and 5 times 2 will give the summation as 10, which is basically this kind of ordered pair. Okay, and only one case we know that this is only one case. If you want to go mathematically, then you should say 5 numbers arranged among themselves in 5 factorial. Since they are in repetition 5 times, divide by 5 factorial. Still you are getting 1. Okay, so that's the last case. And if you add all the cases, case 1, 2, 3, 4, 5, 6, you will get the summation as 89. So 89 is the correct answer. So I will say this is a level 2 question. Not that easy, not that tough. Okay, so a level 2 question. Good question. Coming to question number 4, which is a level 3 question. Suppose we uniformly and randomly select a permutation from the 20 factorial, which is nothing but permutation of 1, 2, 3, 4 up till 20 digits, right? What is the probability that 2 appears at an earlier position than any other even number in the selected permutation, A, B, C or D? It was asked in GATE CS 2007. Pause the video, try, then look at my solution. The solution is option B. A lot of students will mark D, but D is wrong. The correct answer is option B. In a lot of books also D is given, which is wrong. Okay, correct answer is B. How come? Why come? Let us see. First of all, by looking at the question, you have realized that 20 factorial, if they are saying these are the digits and 20 factorial, which means digits are not repeated, no repetition, then only you can say that 20 dashes we have and 20 numbers arranged among themselves in 20 factorial, which is nothing but 20 into 19 into 18 into 17 into 16 into 15 dot 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 up till 1. That's how your 20 factorial comes. So it's without repetition. The criteria is 2 appears at an earlier position than any other even number in the selected permutation. You know what? A lot of students will follow the method 1, which is correct approach, and see the problem in method 1. So we know that probability is requirement by total. Total ways of arrangement is 20 factorial, which means repetition not allowed. In the requirement, 2 appears before any even number. So there are various such cases, such as case 1, 2 is taking the first position, then the 19 places are left and it can be taken by any 19 number. In that scenario, 2 will always appear before any even number. Makes sense? So 19 places, 19 number, 19 factorial ways. Coming to the second case, where 2 is taking this second position. So even number cannot come here. If even number came here, this criteria won't be satisfied. So even numbers should not come before. Then who will come before? Odd numbers only. So for this places we have odd number. But in 1 to 20, how many odd numbers are there? You can do it manually and count, but if you know 10, it's well and good. Otherwise you can say 1 3 5 7 9 and then 11 13 15 17 19. Okay, so total we have 10 odd numbers. If we have 10 odd numbers, then that first position will be taken by the odd number, so 10 possible ways. Then we have the remaining dashes, which are nothing but out of 20, 2 dashes are gone, so 18 dashes. And 18 dashes and 18 numbers. How come 18 numbers? Because one number is gone here, one number is taken here, so out of 20, 2 are gone, so 18 are left. 18 places 18 number, 18 factorial. So the total numbers which will be generated from this is 10 into 18 factorial. This is what the total number will generate for the case 2. Similarly, case 3. Case 3 means 2 is taking the next position, which means the third position. Previous 2 should be filled by the odd. So first dash has 10 odd possibility, 1 is gone here, then the next will have 9 odd possibility. Then we'll say the numbers which are after 2, these are 17 places, and 17 places and 17 numbers will be filled by 17 factorial ways. So the final answer is 10 into 9 into 17 factorial. So this is our third case. Similarly, fourth case will be generated 10 into 9 into 8 into 16 factorial. Then fifth case, sixth case. How many such cases will be generated? See, how many such cases is a very good question, because 2 is taking first place, then second, then third, then fourth, then fifth. A lot of people are thinking it will take up till 20 such places. No, no, no. We have 10 set of even number as well, right? And 10 set of odd numbers. So 2 cannot take up till 20th position. Otherwise, the even numbers will go ahead of the 2. And we want no one is going ahead of 2, right? Everyone is after 2, and 2 is at the first position. 2 is always at the top, at the ahead position, right? Okay, so if you see carefully, then in the 20 dashes, the last scenario which I am generating is by saying the first 10 dashes are taken by the odd numbers. Okay, first 10 dashes are taken by the odd number, and the next 10 would be all the even numbers only, right? In the last case, all even number, but we need 2 is before every even number. So 2 is taking the 11th place. 2 is at the 11th place. That is the only last case. After that, blunders will happen, unnecessary cases will happen. So 11th case, 11th place and 11th case is the last. Okay, and this is how you have to generate one by one cases. So first place 2, first case, second place 2, second case, third place 2, third case, fourth place 2, fourth case, 11th place 2 and 11th case. Okay, so now you have to add all the cases to get your requirement. If you see the pattern, it would be easy for you. 19 factorial plus 10 into 18 factorial plus 10 into 9 into 17 factorial plus 10 into 9 into 8 into 16 factorial. Next would be what? 10 into 9 into 8 into 7 into 15 factorial. Next would be, yes, you are getting the idea now. This is how the pattern looks like. Okay, so 19 factorial, this thing you have seen, right? Then next would be 10 into 9 into 8 into 7 into 15 factorial. Next would be 6 into 14. Next would be 5 into 13. Next would be 4 into 12. So on and so forth. If you go, you will get your answer. Okay, so these are your 11 cases, 11 requirements. If I am adding, this is what I am getting. And finally, probability is requirement by total. Simplify and get the answer. I know 1 by 10 I got. It looks simple, but if you do in the GATE exam, it will take a lot of minutes to get the final answer. Indeed. So therefore, method 1 was problematic. So while solving the final thing was a problematic. Not the conceptual way. Conceptual way was easy. Solving the final thing is a problematic, and getting the answer as 1 by 10. If the options were such as we have solved, then well and good. So the problem was, since we got a very big kind of equation at the last, lot of people in the books also, they are marking none of this. But that is wrong. If you simplify, you will get 1 by 10. So is there any other way to get the answer? Indeed. You can use a very simple logic method too, a trick, a very simple logic. Since it is uniformly and randomly thing done, So uniform distribution equiprobable for the every digit. So they are asking probability that 2 appears at an earlier position than any other even number in the selected permutation. So how many even numbers in total we have? 2, 4, 6, 8. If you check it out, 10 even numbers we have. In that you need 2 appears at an earlier position than any other even. So that is the only one case. 2 before other is the only one case like this. 2, 4, 6, right? Only one case. So one case out of 10. So 1 by 10 is the answer, as simple as that. A very basic logic to get the answer. Okay. If you want, you can also do by the combination as well. But this is a very simple thing to get the answer. So I hope you got the idea. Going to the question number 5. 4 fair 6-sided dice are rolled. The probability that the sum of the result being 22 is x by 1296. The value of x is what? NAT question asked in GATE CS 2014 set 1. Pause the video, try, then look at my solution. So it's not that tough, since you know probability questions how I solve. Requirement by total. So what is total? 4 fair 6-sided dice are rolled. So 6 to the power 4 is the total cases, right? And then they need the requirement as sum of the result being a 22. So first die outcome plus second die plus third die plus fourth die outcome results to 22. This is what they need. Okay, so what is the example which you can think? 6 plus 6 plus 6 plus 6 is 24, but they don't need that. So 6 plus 6 plus 6, 18 plus what? 18 plus 4 will lead to 22. So yes. So how many cases can be generated? You can do it manually. 4 can come here, 4 can come here, 4 can come here. In this way 4 cases are there. Or simply permutation, numbers arranged among themselves in 4 factorial ways, then repetition is 3 times 6, so 3 factorial. So 4 cases will be generated. The next case you can think of is 6 plus 6 is 12, and then I need 10 to make it 22, so 5, 5. Okay, so again if you use permutation, 4 factorial by 2 factorial, 2 factorial, 6 would be the outcome. If you do it manually, you might fail to get some cases, right? So permutation is the best way to avoid any confusion. Just do the arrangement. 4 factorial by 2 factorial, 2 factorial comes out to be 6. So total requirement has 10 such possibility. So probability is requirement by total 10 by 6 to the power 4, which is 1296. Given thing was your probability comes out to be x by 1296. So if I do the comparison as per the given, probability comes out to be x by 1296, and I solved and I got 10 by 1296. So just compare the numerator, you will get x is 10. That is the answer. Easy, isn't it so? So two things were there, probability concept and the permutation concept to get the answer. To the next question and the final question. When 6 unbiased dice are rolled simultaneously, the probability of getting all distinct numbers 1, 2, 3, 4, 5, 6 is what? A, B, C or D. GATE CS 2024 set 2. So it's not that tough question. Again easy question. Probability is requirement by total. Total is what? 6 unbiased dice. So 6 to the power 6. Requirement is what? All the digits in your 6 dice throw, they are distinct. Okay, so number of outcomes would be, use the permutation, right? 6 dice, 6 numbers, number of outcomes would be 6 factorial. Simplify, you will get the answer as option A, like this. Okay, 6 dice thrown, 6 outcomes should be distinct. First get the 6 chances, second have the 5, 4, 3, 2, 1, right? Multiply them, you will get this many sets, right? So this many ways where distinct outcomes are there. So requirement by total, you can see that 3 2s are 6 and this is also 6. So basically 6 to the power 4 is left. One of the 6 can be used to cancel out here because they have the presence of 2. Just the simplification part which I should not tell, but still if you want, this is what your things look like. We have 5 and 4 and 6, then we have 6 to the power 2, 6, 6, 6, 6, right? So 6 to the power 2s are gone. Then 2 3s are, this is 2s are, 2 1s are, 2 2s are. If you simplify this, you will get 5 by 3 2 4. That is the final answer. Easy, isn't it so? So this question was easy indeed. Then you have seen this question was also kind of moderate but easy only. This question was level 3 if you are going with the method 1. Otherwise method 2 makes it super easy. but then your concept should be strong. This is also a level 2 question where analysis is required. Indirectly, arrangement of repeated letters is what they are checking. Okay, type 4 permutation concept. And then this is also a level 2 question where you have seen analysis is needed to get the answer. Otherwise, it's like a choices and a boxes. First box get how many choices, second box get how many choices. It's like the counting principle which we have seen, right? Then this is also a level 2 kind of question. Analysis is needed, 0 positions fix and then get the cases, or simply use some critical analysis to arrive at the answer very fast. So that's it for today. I hope you enjoyed the class.